Hi, so this question says determine AX, which is parlance, is the terminology for the X component of this displacement vector, and also AY. Um, so let's visualize it. Again, I'm gonna draw my own diagram. I don't like using the diagram supplied to me because often the diagrams are not careful enough. As a teacher, you tend to use generic diagrams. Um, for instance, this 25 degrees looks way bigger than 25. So the first thing I'm going to do is try and draw that a bit more carefully. And also, this is not really long enough for my purposes. I know that this is 25 degrees here. And the first thing I want to find is my X component. So again, I imagine a light above a wooden arrow. And I'm asking myself, how long is the shadow that's cast by that light? And so I imagine that the edge of the shadow is the downwards projection of the tip. And so I have my X component. And I've practiced my trig. So I can say that if this is 7 meters long, then I can say, just by looking at it, that this is 7 cosine 25 meters long. And the reason I know that is because this is the hypotenuse, and I'm using the angle between my original vector and the component that I want to find. And when I use the angle between the original vector and the component that I want to find, then it's a cosine of that angle. I don't know the numerical value as yet, but I can figure that out. That's just a bit of math. And then on this side, we're going to imagine projecting. Now I've got the light at the right of my page, and I'm imagining the shadow being projected against a vertical wall. And I'm asking myself, what is the size of the shadow that goes vertically? That is the Y component. And then this is going to be 7 sine 25. Because if this is 7 and this length is the same as that length, and this length is an opposite to my angle. Opposite over hypotenuse is a sine. If you like, if this is 25 here, we have 25 here. Opposite over hypotenuse equals sine. So one way or another, I learned to be able to write these things down carefully. The one thing actually I'm going to add is that this is pointing in a positive direction. They won't always point in a positive direction. So this is my positive y, and this is my positive x. So it's a vector, and it has direction, and directions have signs. So that would be plus 7 uh, sine 25, and I'm going to go back and improve this one and say this is plus 7 cosine 25. So then I can get my little calculator out and I find that 7 cosine 25, in fact, I'm just going to double check now. Let's look. 7 cosine 25 is equal to, and I'm getting it's going to be plus 6.344 meters. And then for my next value, it's going to be 7 sine 25, and that's going to be plus 2.96. They're the precise answers, and I guess in my key I rounded it. So the 6.344 became a 6.3, and the 2.96 became a 3.0. So these can be rounded to 6.3 positive meters, and this could be plus 3.0 meters. And there's my answer. So I find it 6.3 and 3, which is this guy there. As usual, from a strict uh, um, significant figures determination, I've only got one significant figure here. So that should really limit my answers to one significant figure. The fact of the matter is that many teachers don't like to use complicated numbers here, so they get complicated numbers there. So I'm quite comfortable using a one-digit number here, but saying to my class, "Hey, give me one or two decimal places, so I can see, uh, um, I can be more careful about what your answer is." So there we have it. It's a standard skill. Find the x component, find the y component. And again, you can get to this stage pretty quickly where you can just see these. One point before I leave, I could have just as easily have said, I'm going to put this in red because it's a additional step. Rather than saying 7 sine 25, I could have decided, oh well, this is 65 degrees here. And I could have said, oh, this is plus, because it's still pointing upwards, 7 cosine 65. And remember, of course, numerically, cosine 65 is the same as sine 25. They're numerically the same value. So it's just a different way of analyzing. And the same down here, rather than using the 25, I could have used the 65 and said that this is plus 7 sine 65. So there's nothing sacred about using the 25. It is getting the right answer. So some people only want to work in cosines, and so they're prepared to go from the 25 to the 65. But eventually people get to the stage where they say they can just see it. A second word of caution, just because it's horizontal does not mean to say it's always a cosine. And some people fall into the trap where, because things are horizontal, no matter what angle I give them, it's going to be the cosine. And that can lead to a lot of problems. So there we have it.